In this video, we're going to do 16, 17, and 18. Amy has 6 blue, 2 red, and green books to arrange on a shelf. How many distinguishable ways can these books be arranged if the book of the same colors are identical? All right, I want to highlight 2 things. How many distinguishable ways can the books be arranged if the book of the same color are identical? And I'm going to circle the word identical. When you're trying to arrange items and items of a same group or characteristic are considered identical, you're going to use what is known as the distinguishable permutation formula, or the permutation formula for alike objects. And the key word in this case is being alike, being identical. So to find out how many ways we can arrange distinguishable items, non-distinguishable items, I should say, items that are considered the same, the formula that we're going to use is n factorial divided by k1 factorial times k2 factorial all the way to k of m factorial, where m represents the total number of categories we have, and k1 and k2 represents the categories themselves. N is how many items you have in total. Let's find what n is. N represents how many things we have in total. We have 6 blue, 2 red, and 3 green. 6 plus 2 is 8. 8 plus 3 is 11. There are 11 books in total. Now we're going to go with K1. And K1 is going to be the blue books. And how many blue books do we have? We have 6 blue books. K2 is going to be the red books. How many red books we have? We have 2 red books. And then K3 is going to be the green books. We have 3 green books. So to find our distinguishable permutation or our identical permutation, we can now plug the values into our formula. That is going to be on top 11 factorial divided by K1 is 6. So 6 factorial times K2, that is 2. So 2 factorial. And then when it comes to K3, or case of 3, that is going to be 3 factorial. Now I'm going to do this in 2 ways. Factorial means to multiply from that number down to 1. So I'm going to do it the short way, and then I'm going to do it the longer way. Rather, I'm going to do it the longer way first, then the shorter way second. And then moving forward, I'm going to do it the shorter way every time. So we want to use our factorial feature. For 11 factorial, that's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1. Let's double check to make sure that this is correct. Oh, what's going on here? Okay. Now let's do 6 factorial. 6, oops, let's delete one of those 6's, times 5 times 4 times 3 times 2 times 1. That's 720. 2 factorial is just 2 times 1, which is 2. And then 3 factorial, 3 times 2 is 6. 6 times 1 is also 6. Okay, so let's put this all into our calculator and then divide. Let's zoom in just a little bit better. Okay, let's go to the calculator. 399,16800 divided by, in parentheses, that's going to be 720 times 2 times 6. And the overall answer is going to be 4,620 different ways. Put that right here. 4,620 ways. And that is the answer to this question. Now, I'm going to go back to here for a second. And instead of me multiplying out all these numbers, I'm going to use my factorial tool in my calculator to make calculating a little bit easier. So let's go back to the graphing calculator. Put your 11 in first. Actually, let's delete that. I don't mean to put that there. Hit enter. 11. Now go to math. When you go to math, go over to PRB. Mine says PROAB. Don't worry about that. Yours will say PRB. And go down to the fourth option, which says factorial. Now, divide that in parentheses by 6 factorial times 2 factorial, then times 3 factorial. And you get your answer of 4,620 as well. All right, let's continue. Number 17 says 10 people are bowling. 3 will use black balls and 7 will use blue balls. How many different black and blue bowling balls sequence can occur on the rack? When you are bowling, a ball that is black or blue are considered identical. They differ in terms of weight, but the weight is not being specified. The color is being specified. So we're going to say that the blue balls are identical. And we're going to say that the black balls are identical. Which means we're going to use the permutation formula for when things are alike or identical. N is how many balls I have in total. N is 10. There are 10 balls in total. K1 is going to be the number of black balls we have. We have 3 black balls. K2 is going to be the number of blue balls we have. We have 7 blue balls. To compute and to find how many ways that we can arrange the sequence of balls on the rack, we're going to now use our permutation formula for identical objects. That is going to be 10 factorial divided by K1 is 3, so 3 factorial, times K2. K2 is 7, so it's going to be 7 factorial. And we can now go back to our calculator and use the factorial operation. So 10 factorial, you want to go to math, hit your factorial, divide in parentheses, please, parentheses, 3 factorial times 7 factorial. And that equals to 120. And there you go. And the last one, number 18. How many distinguishable permutations are possible in the word Tennessee? Distinguishable permutations, once again, means to use the permutation formula for alike objects. So n factorial over k1 factorial times k2 factorial all the way to case of n factorial. Case of m, I mean, factorial. Okay. How many letters are in the word Tennessee? 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 6, 9. N equals to 9 letters. And the reason why we're using the distinguishable permutation is because the letters that repeat are considered identical. Now, K1 is going to be how many T's are in the word Tennessee. There is 1 T. K2 represents how many letter E's are in the word Tennessee. 1, 2, 3, 4. There are 4 E's. K3 represents the number of N's in the word Tennessee. And there are 2 N's in the word Tennessees. K4 represent how many S's are in the word Tennessee. And there are 2 S's in the word Tennessee. Now we can plug it into our distinguishable permutation formula and then get our results. 9 factorial divided by, that is going to be 1 factorial times 4 factorial times 2 factorial and then times another 2 factorial. Let's plug that into our calculator. Nine factorial divided by, in parentheses, that's going to be 1 factorial times 4 factorial times 2 factorial times another 2 factorial. Close that up. And there is our outcome. 3,780 ways. So this is going to equal to 3,780 distinguishable permutations. Now, do not confuse this with a regular permutation. This is a distinguishable permutation, a permutation when objects are considered alike or identical. Let's zoom out so we can see everything. So once again, for number 16, the books of the same color are considered identical. For number 17, the bowling balls are in terms of color, blue and black. The blue balls are identical. The black balls are identical to each other. And for number 18, the letters in the word Tennessee, if they repeat, they are considered identical. I'll catch you in the next one, guys. Take care.